Hello, it's James from Technical Topics. This afternoon doing a quick video on cranking compression test using Pico. So we've got Pico scope here, you just about see it. We've got an overhead valve engine and we're using two main input types. We have a current clamp around the starter motor and we are using a Ditex pressure transducer in the exhaust pipe. And the idea is to show a quick video of how easy it can be to get engine condition test. So we've got the Pico set there on the screen. I've got it set on two channels, so one channel is cranking out, second channel is the pressure pulse, and we've set up something called a single trigger. So the single trigger allows an event to happen and then the scope will record the beginning of the event all the way through to the end. So we'll do a quick capture, we'll see what we get up on the screen, and then we'll have a short discussion about what's what. To crank this engine over, I've got a super duper start stop switch, so what I'm going to do is press that, we'll let the engine crank for 5 seconds and then we'll come to the screen and have a quick look and review. So here we go. And then we stop. And when it gets to the end of the screen, it should hopefully have recorded that cranking effort. So now for the analysis. So what we can see are the red lines here are the pressure pulse sensor and the blue lines are the cranking amps. So we can look at one or other in combination. Cranking amps on its own is a brilliant first test. If we just pull the pressure pulses out of the way, if I come in here and have a little zoom, the cranking compression waveform is taken from the starter motor current, and the current changes in the starter motor as the engine is rotated up towards TDC. So the more compression that we have, the higher the current, and we can see these peaks going from low to high and then back to low, and each cylinder TDC in compression gives me a peak of the line. There's several things that we can do very quickly and easily. We can pull a cursor line, measure the relative heights, and then we're looking for a relationship between the peaks. So they all look pretty deep and crisp and even. There's no high, no low. There is a rule of thumb which we can use. We take the cranking amps of the start of the battery, so the amp hour rating of the battery, we multiply that by 3, and that gives me a ballpark figure for what should be an acceptable cranking value. 45 amp hour battery, we got on the screen there 160 on the peak, the average will be about 150. So in terms of is the compression in the ballpark of what we expect, then yes it is. Second thing we can do, so we don't have one low, obviously if we had a compression out, the peaks in sequence, one of them or two of them or three of them would be low, or 4. There are some other things to watch for which go beyond the scope of what we're trying to cover today, but for instance odd peaks, not necessarily low but also high, can indicate internal malfunctions. Now the really good thing about this test method is it takes, as you've seen, one clamp to go around the battery cable, a 5 or 10 second crank, and a little bit of analysis work to tell whether or not you've got fundamentally an engine problem. So imagine that in the context of a diesel engine where you'd have to pull glow plugs, we don't have to do that, or petrol engine where stripping the engine down on a car that's marginally valuable in terms of the repair, whether it's worth doing or not. We can still leave the car. If it was misfiring, we can give it back to the customer in exactly that condition. Now that's the initial inspection. If we come out with my zoom now on the Pico, if we get rid of the zoom and then drag down my pressure pulses, this is where we start to fill in the gaps. So essentially we could think of our cranking amps as the headline. Do we have a major malfunction, yes or no? And then we can look at the pressure pulses as the detail. If we have a problem, where is that problem evident? So the pressure transducer that we have currently in the exhaust pipe can be fitted in 3 locations. Location number 1, it can be in the exhaust pipe. Location number 2, it can be in the intake manifold. Location number 3, it can be in the dipstick tube. And these will give you triangulation for your gas leakage, if you like. So a lack of compression shown by the current clamp can be because it's leaking out the exhaust valve, it's leaking back the intake valve, or it's going past the rings into the crankcase. If you don't have any of those conditions present, the other option, so the fourth option for why we have a low cranking amps waveform, is that the compression isn't being generated because something's bent. And so really we flush out the 3 options of gas is leaking, and if no gases are leaking, then we're down to a lack of compression. Other factors that can cause compression issues, but they're more global than single cylinder, are things like blocked or restricted intakes and exhaust pipes, which are affecting the engine's ability to be an air pump. So lots going on. Anyway, enough about that. Let's have a quick look. I'm going to zoom in now and pick up on 4 pulses. Why 4 pulses? Well, we've got 4 cylinders in our engine, so if we pick up 4 pulses, we should get a bit of a look around 4 cylinders. I'm going to just do a little bit of tweaking here, so I'm going to go down to the magnification, zoom on in, and I'm going to increase the amplitude of my cranking amps to give me a rough idea and a sort of exaggerated idea of what's going on. I'm going to pull my pressure pulses out of the way, and I'm just going to tweak the waveform ever so slightly, so we're having a slightly different view on the amplitude of the pressure pulses. So it's been thought of as the pressure pulses are akin to reading tea leaves. So with the mystery people that shake their teacup and say that your Auntie Millie's going to die in 6 months being run over by a dog, okay, this type of thing has been reflected to reading the pulses. On the very base level, so with the current clamp and the pressure transducer in the exhaust pipe, what we're looking for is parity, or Sesame Street diagnosis. Sesame Street, when they're teaching kids about fruit, they have 3 apples and an orange, and they sing this song that one of these things doesn't look like the other. One of these things just ain't the same. And this is what we're looking for on our pressure pulses. We're looking for deep and crisp and even and repeated patterns of chi and good. When we have a deviation, we see low in the current, and then we see a fluctuation in the pressure, and we can start to get some level of correlation. Okay, that's it. Quick summary. Some idea of what's going on. We deal with this subject in great depth and detail in our oscilloscope masterclass and oscilloscope courses on our boot camp and another scope related training. So if you want to learn more, give us a shout. We've got the website there in the background. Pop on there and have a quick look. You'll see training courses aplenty. Come on down and experience hands-on the depth and detail that you can get very quickly and easily. Thanks for watching. See you soon.